these two substrates want to react, but it takes a lot of energy. As you can see by this graph, it takes a lot of energy for them to react and for the reaction to then go to completion. This amount of energy that's needed at the top is called the activation energy. It's energy required for the reaction to go to completion. So what we do in biology is that when you have a reaction that takes a lot of energy to go to completion, you have an enzyme. An enzyme will hold these two together so that they can react more easily, and so that the amount of energy needed to have them react is less. So then when you put these two together in the active site, this protein will fold over them. No, that's weird. Let's not draw that. I'm just saying, this protein will fold over them on both sides, and they'll react with less energy. So when you look at this graph without an enzyme, it's going to look like this. But when you have this graph with an enzyme, your activation energy will lower, as you can see here. So this is the graph with the enzyme. You need less energy for the reaction to go to completion, and you're still using the same substrate. So that's the purpose of an enzyme in any cell, is to lower the activation energy for different reactions that go on in the cell. Okay, so this enzyme that we were just talking about, this enzyme is specific for these two substrates. This enzyme only works for the reaction between these two substrates. If we had like a substrate 3 and a substrate 4, the reaction between these two, it's not going to be catalyzed by this enzyme. You're going to need a whole different new enzyme that's specific for this reaction. So this enzyme is only specific for these two. Now let's say that when this enzyme catalyzes this reaction, we know that enzymes are proteins. And so this active site over here of this enzyme, let's say the amino acids are this one and this one that are in this active site, right? Let's just say there's these two big amino acids, right? These two most important amino acids. So as you can see, one of these amino acids has a small R group, and one of these has a really big R group. So when this process occurs, when this reaction is catalyzed by this enzyme, the only reason it works is because this enzyme has a small one and it has a big R group. Let's say if this R group, this small one, were to become really big all of a sudden, let's say it was mutated or something, right? Let's say the cell made a mistake and it was mutated. What would happen to the enzyme? Would the enzyme still catalyze this reaction? That's a question I want you guys to answer, and I want you to tell me why. Why would the enzyme be able to catalyze the reaction, or why would it not be able to catalyze the reaction?